See our next point, electric potential. To show this figure, first AB is creating a dipole. So what is electric dipole? Electric dipole means a negative charges creating a means opposite charges creating a dipole, means plus q or minus q creating a dipole, but not a same charges, means plus q or minus q creating a dipole. Okay, so this plus q situated at A point and minus q situated at B point, so it's creating this dipole. Now we find out electric potential at point C. So this dipole is divided in equal part, so length of the dipole is 2L. So here divided in AO and OB. So length for AO is L and length of OB is L. Now draw this line from C point to O point and extend up to Y point. So here creating YB is perpendicular to the point B. Then at A point draw a next perpendicular line to join the YC line at point X. So this angle at point X is perpendicular, means 90 degree, and at point Y is also 90 degree. Then makes an angle in between AOX and YOB is theta. So these two angles is same because the opposite angles. Then so distance from A to C is R1 and distance from the C to B is R2 and a distance from C to O is R. So now here we get a R, R1 and R2, L and is also M. So understand this figure. Let us see our expression. So let's see with any point near the electric dipole at a distance R from the center O, incline at angle theta with axis of the dipole, this theta, using a dipole. We already see this figure. So then R1 and R2 are the distances of point C from charges plus q and minus q. So at respectively. So at plus q distance is R1 and at the minus q distance is R2. Draw AX is perpendicular to OC and by BY. Okay, then potential at C due to charge plus Q at A is. Now this charge also gives a potential V, we already learned, and this point charge also gives a potential V. So at A point we consider a potential V1 and at B point we consider a potential V2. So formula for potential V1 is equal to plus Q upon 4 pi epsilon naught R1 is distance from A to C, and similarly for V2, so V2 means potential at point C up due to charge minus Q. So V2 is equal to minus Q upon 4 pi epsilon naught R2. So these two charges give the potential. So we already learned V means work done upon charges, means work done per unit charges. So now here two potentials V1 and V2. So the potential at C due to a dipole is, so VC is equal to V1 plus V2 means addition of two potential. So adding these two equations, we get Vc is equal to plus Q upon 4 pi epsilon naught R1 plus minus Q 4 pi epsilon naught R2. So first set out the same point, same values. So Q upon 4 pi epsilon naught, the similar point. So put up the outside of the bracket, and then remaining term is 1 upon R1. Here minus sign, so here minus, and then we get 1 upon R2. This is the bracket. This is the equation number 1. So now the main part in this expression is in a triangle. Now this main part start from here. In a triangle BYO. Now this is the figure. BYO shows this triangle, and AOX shows this triangle. Okay, so using these two triangles, we find out the values of OY and OX, because these 2 points are, we know that already. So we know that the trigonometric cos theta is equal to, this is the theta, so cos theta is equal to adjacent sides upon hypotenuse. So here theta, so adjacent point is OY, and so OY upon L means hypotenuse. Hypotenuse means this L. So we get here value of OY. So OY is equal to L cos theta. Rearranging this equation. So similarly for OX means also we get a L cos theta. Okay, by using this cos theta upon OX upon L. OX upon L. So we get here OX is L cos theta. So here OX is L cos theta. So now from figure, R2 is nearly equal to YC. So again see the figure. Let us see here. R2 is nearly equal to CY or YC in this line, similar to R2. So we get here R2 is equal to, means YC is equal to OY plus OC. So we get here R2. Okay, value of R2 is, means YC is addition of OY or OC. So we know that the value of OC is R and value of OY is, we already find out here, OY is L cos theta. Let us see here L cos theta. So now put up this value, then we get R2 is equal to R plus L cos theta, and similarly R1. So R1 is nearly equal to, now CX. Okay, so R1 is nearly equal to CX. So now CX means OC minus OX, because we only getting this CX value. So here OX is minus out. So we get value of R minus L cos theta, because we get OC means R, and so minus of OX we already find out L cos theta. So put up this, then we get a value R2 is equal to R plus L cos theta, and R1 is equal to R minus L cos theta. Okay, now putting this value in of R1 and R2 in equation number 1, we get, so Vc is equal to Q upon 4 pi epsilon naught 1 upon R minus L cos theta minus of 1 upon R plus L cos theta. So Q upon 4 pi epsilon naught in bracket of its cross multiplication R plus L cos theta minus R plus, here minus get plus L cos theta. Okay, So here R plus and R minus cancel out, and we get here plus L cos theta and plus L cos theta, we get 2L cos theta. And here 2 points, here R plus L cos theta bracket up, and in bracket of R plus L cos theta. So minus and plus, using this formula, mathematical formula, bracket of A minus B bracket complete, then bracket of A plus B bracket complete is equal to A square minus B square. So using this mathematical formula, we get A means R and B means L cos theta. So R square minus L square cos square theta. Okay, then so we get a VC is equal to Q upon 4 pi epsilon naught 2L cos theta upon R2 minus L square cos square theta. Okay, now here this value Q into 2L, this is the nothing but the momentum P is equal to Q into 2L. So this put up the value P and cos theta upon 4 pi epsilon naught R square, because of L square cos square theta is equal to 0. Now this theta means 90 degree. So we get here cos 90 is equal to 0. So this term is 0. And then we get VC is equal to P cos theta upon 4 pi epsilon naught R square. So this is the electric potential expression for electric potential due to an electric dipole.